Our project investigates the differences in behavior of Newtonian and non-Newtonian fluids when spun on a rotating drill bit. Here we see paint, a non-Newtonian fluid, being projected in drop strand formations from the bit as it rotates. This system of rotating fluids can be modeled using the equations of rotational motion.
By applying Newton's second law to an infinitesimally small mass of fluid, we can determine the relationship between forces and the net motion of any fluid parcel. In a rotational frame of reference, the flinging of droplets and the formation of strands is a product of balancing radial forces. Angular momentum imparted on the fluid by the rotation of the bit creates an outward centrifugal force, which is countered by tensile effects due to the fluid's viscous nature.
Paint, a pseudoplastic or shear thinning fluid, exhibits lower viscosity as stress increases. To explore a different stress strain profile, we look at oobleck, a dilatant fluid with shear thickening properties. The increasing viscosity of dilatant fluids means they act more solid-like at higher stresses. The result is that the oobleck curves significantly less, instead forming radial columns projecting outward from the drill bit.
How do these rotational fluid mechanics apply to Newtonian fluids? These fluids, like honey, exhibit constant viscous coefficients. With relatively low viscosities, they produce drop strand formations similar to paint.
However, at half the rotational speed, the honey lacks enough angular momentum to overcome its cohesive internal forces and thus does not escape from the drill.
The fluid's viscosity determines both how easily the fluid is ejected from the drill bit and the length of the drop's connecting strand. Oil, a lower viscosity fluid, exhibits shorter strand formations due to the lower shear strength of the fluid.
Toothpaste, a Bingham plastic, won't strain until minimum shearing stress is attained. In this experiment, the drill's RPM doesn't generate sufficient stress to induce deformation in the toothpaste.
Ultimately, this experiment provides an excellent illustration of how different shear stress strain profiles affect the mechanics of fluid rotation.